Okay, welcome to virtual GED class. We are continuing our series here that we've been doing on data analysis. And I'll just remind you guys again, data analysis doesn't only appear on the math test. We're going to see it on science and social studies. So we're prepping here for 3 tests at once. Pretty exciting. But today we are going to be looking not at all data displays, charts, and graphs, but we're actually going to be looking at circle graph. Circle graphs have another name that they often go by. Some people call them pie charts, circle charts, pie graphs, all the same thing that I'm talking about. And when you talk about circle graphs and pie charts, what you're talking about is looking at data as a piece of a whole, looking at data as a piece of a whole. What is a circle graph or a pie chart? Oh, pretty simple. It's the circle. Okay, so not too stressing. I have one over here, but just some features I want you to notice. You'd better have a title on your circle graph that tells you what it's about. I love GED students. They're my people, okay? I teach you guys for a reason. I adore you to death. But one of the weaknesses, as I was saying, of GED students is that they don't tend to pay attention to detail. You guys rush right into the numbers, start crunching numbers in your calculator without knowing what's going on. So it's really important. Pay attention to the title of your graph. It's going to give you information. This one we see, it's the Milton's family budget. Check, title. Another feature of a circle graph I'd like you to notice is that we have discrete categories. Discrete. So we talked about this a little bit when we looked at our frequency-focused graphs. Does anybody remember what I mean when I say discrete categories? No? Okay, so there's no overlap of categories. Each group stands alone. So if you come look over here on my graph, food is food and rent is rent. You know, that's 2 separate, totally distinct categories. And that is what I mean by discrete categories. Like I said, a circle graph shows you a piece or a part of a whole. So the circle, the entire circle, represents the whole. So the whole what? Well, in this case, refer to the title to know what I mean of the whole. In this case, that circle refers to the whole Milton family budget, the whole thing. And then each piece or part we can see is a portion, a ratio of a whole. Okay, now the ratio or proportions of each category are usually most often expressed as a percent, which is why we're doing this right now, because we've been digging into percents lately. I included this because it's super useful to know, but we already talked about it a little bit. The pie chart displays data as a part of the whole, and make sure your sections are labeled. But we have some advantages and disadvantages of this type of graph. So one of the advantages is that it's very visually appealing. We looked at some of the frequency-focused graphs the other day, and you guys were like, ooh, that's ugly. I hate that. Pie graph is pretty simple to glance at and understand, okay? And again, we like that. We see that in a proportion or a ratio, a percent of the total. Okay, but there are some disadvantages to a pie chart. Take a look at the number 1 disadvantage: no exact numerical data. We might know that the Miltons spend 15% of their budget on rent, but we don't know how much money that is. We don't really know how much they pay in rent. We don't have it in dollars. We don't have it exact. Then again, the total is unknown unless specified. We know that the circle represents the total, but we don't know how much that total is unless they tell us somewhere else. It won't be on the graph. And then another kind of weakness to it is that the number of categories you do are limited. When I was making this PowerPoint to show you guys, I saw some examples that had 20 data sets on the same circle. Oh, it was ugly. So many slices and pieces and messy and gross. It was really hard to understand. Okay, so it's best for only 3 to 7 categories. Like we said, it only works for those discrete data sets where each individual set is totally separate and you know, not overlapping, not related there. And then it's also not good for similarly sized data. So for example, if we knew that we spent 24% of our budget on one thing, 26% on another, 23% and 27%. When I look at those in number forms, it's really, really easy to see that they're different numbers. But if I were to put that on a graph, the pieces would be so similar, it would be really hard to tell which one was which. And so it wouldn't be very useful. So it doesn't work very well for similarly sized data. I'm not going to talk about circle graphs. Okay, what are we going to do today? Today we're going to focus on the kinds of problems you're going to see on the GED. So here's the deal about the GED, and Serenity can amen me for this. It is not a memorized computations test. No, they will not give you a bunch of numbers and be like, do you remember how to make a circle graph? It's not going to be like that. It's very much a math reasoning test. So they're going to give you a lot of information. They're going to give you word problems. They're going to give you graphs, and they're going to ask all kinds of weird questions about it. And it's up to you to just figure out what the heck they're talking about. So today's going to be great practice in that skill. So we're actually going to be hitting two of the most important GED math skills today. One, interpreting charts and graphs all over the test. There's lots of pictures and graphs and charts, and can you understand what you see? And two, interpreting word problems. Generally, the GED math problems are word problems, and that is such a struggle for most students. So that's what we're going to do today, pair up word problems with graphs. Gross, but necessary. Okay, so here we go.
The stuff you don't want to do, but you're going to do.
Yeah, it's the real stuff we need practice in. We spend all these times memorizing computations, and then the test isn't like that. And the test is just this reasoning test, which is a very challenging skill. It really is for everybody. It's not like you guys are alone. So I've got a graph and I've got some questions. Now, before I look at those questions, would you guys just examine my graph for me? Read the title. What does the title say? What is my graph about?
Sedan sells import springs by the manufacturer.
Good, yeah. So it's about how many cars I'm selling here. And then look down at my key. Make sure we know what our colors represent. You know, we can see that those colors represent the light blue is the Dodges, and the orange is the Toyota, and so on and so forth. So those are the manufacturers. But do you see the piece of information that's missing from this particular graph? What's missing?
The percents in the graph?
Percents. They didn't give me any percents. And I actually use this one on purpose for this question because I want us to do visual approximations with this graph. So when the percents are there, it's super nice, but can we visually approximate percents based on a graph? Let's give it a try. Okay, so A says approximately. So guys, don't panic. You don't have to have an exact answer. You have to have a decent guess. Approximately what percent of the sedans sold in Port Springs were Fords? So first of all, let's locate the part of the graph that we're looking at. If we're talking about approximately what percent were Fords, where on the graph should I be looking?
The dark blue area?
The dark blue area. Here is my dark blue area. And they want to know approximately what percent is that. And, you know, a lot of students would panic and lose their mind, but you need to remember about the whole thing. So let's start with the whole thing. The whole circle represents what percent?
100.
Exactly. Okay, so let's examine this piece. This piece looks to me as if I had taken the graph, and I'll try to kind of draw the same visualization here, and broken it into 4 equal pieces. Can you see how that blue piece, if I duplicated the size of that blue piece, it would be about 4 equal pieces in that graph? Does that make sense?
Yes.
So I say we should be able to use the stuff we learned on the intro to percent day to say about what percent that blue piece represents.
25%.
25%, exactly. Now, it's an approximation, guys. Do I really know it's 25? No, I don't. It might be 23. It might be 27. Shoot, it might be 28.243%. But I have a decent guess going on, and you need these kinds of skills. When you go to take your test, we can't lose our common sense on this. Now, look how I change it on B because I'm a brat. B says approximately what fraction of the sedans sold in Port Springs were Fords? I'm still looking at the Fords. So I'm still looking at the dark blue piece. But now I want it in fraction form. Help me, guys. What fraction of the graph is that?
1/4.
Exactly. 1/4, also known as 1/4. Is anybody mad at me yet?
No.
Okay, so pretty simple skill, one I want to build. So let's go ahead and do it a couple times more. So C says approximately what percent of the sedans sold in Port Springs were Hondas? So they want me now to represent the Hondas using a percent. Okay, so Hondas, we're looking at what color here?
Gray.
Now this one is trickier. This one's trickier. A little trickier to visualize, a little harder to estimate, but I think that we ought to be able to peg it at least between 2 numbers. Because I know, like, if this thing just went perfectly in half, what percent would that be?
If it went in half, it would be 50.
50. So I can see that that piece is less than half. So I'm
Yeah.
just going to make a little note to myself, less than 50%. Cool. And I know that if I were to break it into 4 equal pieces, I'd get something smaller than that gray. Can you see that?
Yes.
Yeah.
So I know it must be more than
25%.
good. So let's get a decent estimate when we look at it's more than 25, but it's probably closer to 25 than 50. Anybody?
I'll
Like
say like
30.
37.
I heard 30. I heard 37. Is that what you said? 30, Serenity?
Yeah.
How about you? What you thinking, James?
Or it could be 35.
Or it could be 35. Yeah, it's not perfect. We're approximating. I mean, really. My guess was actually 33. Was I right in a range with you guys?
I think so.
Yeah, I was. And so I feel like, if this was on the GED, it'd definitely be multiple choice. So we're all right around that same range. So I think we're doing great. Okay, so I'll put 33, not because I'm superior, but just because I get the pen. So my guess got written down. Okay. But now this one, a little trickier. D says approximately what fraction of the sedans sold in Port Spring were Hondas. So again, I am looking at those Hondas, but this time I want my answer in form of a fraction. And spoiler alert, this is why I ended up saying 33, because I had a fraction in my head. When I looked at this graph, I imagined taking a full circle. So let me take my full circle, and there's about the size of my gray piece. Are you guys cool with that? And I imagined if I duplicated the size of that gray piece around the board, how many I'd get. And I think I'd only be able to get 3 in there. Does that make sense? 1, 2, 3. And so to me, that gray piece looked like about one third, 1 out of 3 equal pieces on a graph.
I understand, but I'm so behind in fractions.
Yeah, and fractions are a real struggle for most people.
Yeah.
The good news with this is when you're doing fractions, this is what you need to realize. Fractions are based on breaking things into equal sized pieces. So I started with the piece I had, the gray piece.
Mm-hmm.
And then I imagined that I was duplicating this gray piece. I was picking it up, Maricela, and dropping it down here and then here again. And I could see it was like that one whole circle got broken into 3 equal pieces. Does that make sense?
Yes. So how about if I want 1 of 8? Is the same thing?
Yes. If I had a little bitty slice like this that I imagined I could duplicate 8 times, then that would be having 1/8.
Okay. So always it's just one piece of the total.
What a great question. Always it's just one piece of the total. It's easiest when it's one piece of the total, but no, there's no guarantee. So let me show you another example. So I want you to imagine that everybody in Port Springs loves, I don't know what they love. They probably love Subarus. So totally different graph now. All this black over here is my Subarus. This is a case where it would not be 1 out of something because I cannot duplicate the size of this Subaru piece. It's just too big. Do you see what I'm saying?
Yes.
So I'd have to split it up a different way. Now, it's not that there's one perfect way to do it, but I'm looking for equal size pieces. So like in this case, I could see equal size pieces that way. Now, my Subaru in that case would represent 3 out of 4 equal sized pieces, 3/4. Fractions are a real struggling point for a lot of students. So number of pieces you have out of total pieces in the pie. And again, those pieces would have to be equal sized in order to conceptualize it as a fraction. Awesome. Good questions. Now we've built up our little visual approximation skill. Let's look at some of these GED style example problems. Okay. So we see this graph again, and let's go ahead and read that title. What does this graph tell me about?
Milton family's budget.
Yeah, so we're looking at the family budget. So now what we see is each piece of the budget represented by a piece of pie. What portion of their money they spend on food, what percent or portion of their money they spend on rent, and so on and so forth. But as we talked about in that slide where we discussed the weaknesses, we have a weakness here on this graph in that we don't know how much money they spent on the food. We just know it was part of the total, but we don't know how much money it was, and so on and so forth. We also, on the graph, do not know the total budget. They did not tell us on the graph. However, please, please, please be the GED student who reads the words that accompany the graph. And in this case, I wrote it over here. You can see that I do give you additional information here. It says the pie chart shows how the Milton family spends the $3,800 in net pay they bring home each month. So I slipped the total into the description, which is what frequently happens, okay? But we don't have a question yet. So let's go on to A. A says, what fraction of their income is spent on Rent. What are they asking me for?
They're asking for a fraction.
They want me to
from
make a fraction. And right now, what do I know about rent?
that it is 25% of their
Yeah,
income.
exactly. I know the rent in terms of percent of income, and they want the rent in terms of fraction of income. They didn't say it specifically, but they're asking me to convert a percent to a fraction. We should know this one. This is one we should have memorized. Help me out. What fraction of their income is spent on rent? We learned on the first day of percent class that the percent 25% is the same as what fraction?
1/4.
1/4. Okay, so now let's talk to the rest of the internet. The people who did not know that 25% is 1/4. What if they missed that class? Okay, how could we turn this into a fraction? Well, I hope you guys remember what percent means. What does percent mean?
Per 100.
Per 100. So you can literally say that is 25 per out of divided by, it all means the same thing, 100. And now, of course, as always, all final fraction answers must be reduced. But if you had this question on the GED, you would have a calculator. You always have a calculator with word problems and these graph problems. So you can reduce fractions in your calculator. I hope you guys remember how to do it. You're going to type the N over D button. You want to put 25 in the top of your fraction and 100 in the bottom. And by the way, if you're struggling to type that in, it might be because you're not in a good fraction mode. It is better to be in math print mode for fractions than a classic mode. So just hit the mode button and switch your modes if you're struggling. But if you're not struggling, you're good to go. 25 goes in the top, 100 goes in the bottom, and then you just press enter, and your calculator knows all final fraction answers must be reduced, so it just reduces without being told. And we do see that 25 over 100 reduces to
1/4.
If you have a TI, I would try doing that in your calculator right now just to make sure you have that skill. But now look at number 2, almost the same question, and yet they say approximately what fraction of their income is spent on food. See how they tell me approximately, guys? I have 100 million students who see that word approximately and ignore it and just start doing the work for what fraction of their income is spent on food. They go, oh, look, 33% on food. I'll convert that into a fraction. That's the same as 33 out of 100. And then they type it into their TI and it doesn't reduce. It stays 33 over 100. And they go, oh, crap. That is not one of my options. I do not know what to do. This is when you need those visual approximation skills, guys. I said approximately what fraction of their income is spent on food. Let's go ahead and take a look at this picture here.
1/3.
Yes, ma'am. It's 1/3. It's not exactly 1/3, but it's close enough for government work. Number 2 is the right answer. How'd you know it was 1/3, Maricela?
Because I did like what you did, you separate like in 3 parts.
Yeah, you imagine duplicating that piece, and it would take 3 of that same size piece to fill the graph. 1 out of 3. Beautiful. If it were only that easy, just converting to fractions, it's not. So let's look at some other types of problems. Again, I often see this on science, social studies, and math. So see, how much do the Miltons spend on food each month? Notice I said how much. Now, if I said to you guys, how much do you spend on food each month? You would answer me, I don't know, maybe you'd say 500, but you'd say 500 what?
Dollars.
Dollars. Thank you. I'm expecting you to go to dollars. Nobody, if you ask me, how much do you spend on food each month? And I said 25%, you'd be like, what? Wouldn't mean
25% of what?
What? Yeah, exactly. 25% of what? So what I want to know is how many dollars do the Miltons spend on food each month? Now, I don't know how many dollars the Miltons spend on food. What do I know?
You know that it's 33% of the income.
Exactly. I know they spend 33%. And I love how Serenity said of the income. I was actually preparing my lecture for when Serenity didn't say of the income. And then I didn't even have to lecture her because she said it. It's 33% of the income or of the budget. And I know that from the title of the graph. Okay. And I need that. I need the of to do these kinds of percent problems. Whenever you say 33%, you should ask yourself 33% of what? So in this case, it's 33% of their income. And this phrase right here tells me just what to do. We did it in our last video. But your TI will do the 33%, but it won't do the of. You have to know what of means. What does of mean?
Multiply.
Multiply. Yes.
Multiply. James, you brilliant thing. Of means multiply. Most people forget that. I am so proud. Okay. And then the income. What's the income we're looking at?
3,800.
Exactly. They bring home those $3,800. That's the money they're divvying up here. That's that total. So if I want to do this in my calculator, I can do the percent button in the calculator, okay? So I can press 33, and then the percent button's in green above the open parentheses. So you're going to have to press second and open parentheses. So 33, and then the second button, and then the open parentheses button, because right above it is a percent sign. And then we said the next thing after 33% is of, so we need to hit times. So I'll hit times, and then we'll times it by $3,800. Now, what if you know how to convert it into a decimal or a fraction? You could totally do that too instead of the percent button. But don't be like the foolish student in my class who did both. They hit percent and converted. I was like, you did the same thing twice. Okay, and I got, whoops, I wrote the answer as the problem. That's what I get for talking while I'm writing. So 33% of 3,800, sorry, and I got $1,254. So how much do the Miltons spend on food each month? They spend 33% of their budget, yes, but that 33% of their budget is $1,254.
It's a lot of money.
Yeah, they probably have a bunch of teenagers, because I think I spend that much, more than that much.
Wait for next week.
What was that, Maricela?
Wait for next week. It's a spring break.
Yeah. Oh, I know they're going to eat so much food. Oh my gosh. Thank you for encouraging me.
You're like, I'm going to need to go to Costco.
I've been going to Costco, girl. So I just want to tell you that 2 weeks ago, I went to Costco. I bought a box of Nutri-Grain bars. Okay. Okay. Do you know how many Nutri-Grain bars there are in there? There's like 50 some odd. There's a ridiculous amount of bars. Okay. Brought them. They were gone in 2 days. So then last week I bought Nutri-Grain bars. I hid them. Don't you tell my kids. There's hidden bars in the garage. I have mama's case. And then there's a case to distract them in the cupboard.
Oh my gosh.
Okay, so y'all can't blame me for my food budget, y'all. It's not my fault.
You can't help it with growing teenagers.
Right, but yeah, $1,254 on food. So I think the Miltons have teenagers. This is the inference I'm making. Look at me inferring. That's why I'm so good at the GED test. Okay, let's look at E. It says, how much would the Miltons save in a year? So I need you guys to be really careful. The GED does not usually feature one-step problems. And I got a lot of students who take the test. They come back, tell me, I felt good. I remember all that stuff from your class. And then they score like a 130 or a 135. And they're like so brokenhearted because they know they recognized all these things. What happened? Usually what happened is you did part of it, but not all of it. You remembered something, but you didn't get all the way to where you needed to go. So let's make sure we make a plan. Look at what I've been asked to find here. It says, how much would the Miltons save in a year? What do we know right now? Well, when we look at the savings, what do we know about savings, y'all?
Do they save 6% of that total?
They save 6% of their income, the total, absolutely. 6% of their total. Okay, now go up and look at that total that I know.
$3,800.
Yeah, what does that thing represent? That's how much they make in a...
They bring home each month.
Month. That's a month.
Oh, okay.
Oh, yeah, watch out. So if I do 6% of that amount, I'm going to be finding the amount they save in a year. Does that make sense?
Yes.
Yes. So, okay, I can find that. It won't be wrong to find that. I just won't be done when I find that. Okay. So I'm just going to kind of note to myself the amount they save in a month
is $228.
Yeah, is 6% of that 3,800. So 6% times 3,800. And you did that in your calculator already?
Yes.
Okay, I'm going to do it as well, except for I have to turn the calculator on first. That's how that works. So I do the 6 and then the percent sign times that 3,800. And just like Maricela said, I get $228. And I'm so proud of myself that it remembers percents. And I check that answer and I move on and I get it wrong because I didn't finish my problem.
Yeah.
Right? They want how much the Miltons save in a year. What am I going to do?
Times it by 12.
Times it by 12. Give me some justification. Why did you choose to multiply by 12?
Because there's 12 months in a year.
Yeah, absolutely. If I save that much each month, I'm going to do that 12 times over the course of the year because there's 12 months in a year. Absolutely. And so 12 times There's a reason why we call multiplying timesing. Means I'm going to want to multiply that by 12. So for a year, it will be 228 times 12. Now, guys, this isn't the only order to do this problem. I've had students do the multiplying by 12 first and then find the percent. You'd get the same answer, so don't panic if you thought about this as a different way. But we would find out that over the course of a full year, they saved $2,736. Very, very GED typical. In fact, the a study guide that tells you the types of problems will appear on the GED, single one-step percent problems don't even occur. It says multi-step percent ratio and proportion problems. So expect it to be multi-step. We've got another graph here. It says all species of living things belong to a larger classification of life, known as a kingdom. The circle graph shows the number of species by biological kingdom. According to scientists, we have about 8.7 million known species of living things. And we come over here to our graph, and we see, again, number of species by kingdom. We don't have a key this time, but that's okay. Each one of our pieces is labeled with both a percent and a title, so we're okay. And then just like the GED, that's all the information. We still haven't reached the question yet, so let's take a look. Our question on A says, how many species are there in the kingdom Animalia? Now, right now, I don't know how many species there are in the kingdom Animalia. What do I know? I know that 62% of all the species are in Animalia. Does that make sense?
Yes.
Yes.
Okay, so just knowing that phrase there will help me be able to figure out how many species that is. Any ideas, guys? What do I have to take 62% of?
100.
8.7 million.
There you go. I've got to take 62% of 8.7 million. Where'd that number come from, Maricela?
Because they said that we have about 8.7 million unknown species of living things.
Yep, and they just say species there, so they're talking about all of them.
Mm-hmm.
So 8.7 million. But I got a problem. If you guys just put 8.7, which is what GED students do, guess what? You're going to get it wrong because that's not 8.7 species. There are not only 8 species on Earth, almost 9. 8.7 million. How do I write that? What you do is you replace the decimal point with the millions comma. That's going to be the millions comma. And then I need enough zeros. So this is 8.7 million. So it's not 8.7 million yet. It's only 870. Okay. It's not 8.7 million yet. It's only 8,700. Keep going until you have 8.7 million. You have 8 million and a little bit more. Does that make sense?
Yeah.
That's tricky. Okay, so now we can type it into our calculator. 62% of means times. And again, I just used the percent button because I'm so lazy. And 87 million, not 8.7. And I get 5394000. Hard to read that number until I put the commas in. So starting at the backhand side, I'm going to go 1, 2, 3, comma. 1, 2, 3, comma, and I see that's 5,394 species in the kingdom Animalia. Let's write that answer here so we can move on. I didn't give myself a lot of space this time, did I? So 5,394,000 species.
I have a question.
Yes.
When I put it, when I put enter, it just hit error. What I'm doing wrong?
It said error. Is that what you said?
The syntax error.
If it says syntax error, you might be using, first of all, you don't need to type in the commas. So don't try to type in the commas. Did you put in decimal places instead of commas, which is very common for people from other countries, Maricela?
I put comma.
Okay, you don't need the commas. You can just put 8700000. Okay.
Okay.
Second thing is, did you use the percent button or the convert to percent button? So that's another very common error.
Okay.
The close parentheses is the convert to percent button.
It comes right now.
Yeah, okay, it's working now. Okay, so we don't need commas in the calculator. You see why it's so important to play with this TI before you take your test? Imagine the panicked feeling you'd have if you saw a syntax error for the first time while you were testing.
Oh my God.
Blew up the calculator, you know? Did that happen to you, girl? Oh, man.
Yeah, once.
That's too much.
The beginning.
Okay. So B says, I just got sorry, I only said that. It's not even for your sake. I just got a girl on the internet today who said, do I really need to buy this calculator and practice it with before the test? I'm like, no, you don't really, but you should.
Yes.
Because you're risking on scoring a lot lower if you don't know how to use this thing. Okay, so B, how many species belong to either the fungi kingdom, fungi kingdom, or the plantae kingdom? I would expect something more like this, where we have a combination going on. So again, I'm looking at how many species. I'm going to have to take these things from percent form into figuring out how many species I have. But this time, yeah, James, you're absolutely right. Fungi are like mushrooms. Yeasts also fall into that category. Yeah, so the fungi kingdom, and then it says, or the plantae kingdom. So I'm looking for species from either one of those groups. So I can look at both of those groups. So let's see, fungi kingdom is 6%, and the plantae kingdom, and I don't even know if I'm saying that right, so you guys all pretend like I'm a scientist, is 16%. Okay, so I want either category. So again, not one right way to go. I want to think about the way you're thinking of this. What are you guys thinking? What should I do here to find out how many species are in either of these categories?
One and go for it, or is it
take one and go for it? Okay, Serenity likes the take one and go for it method. Totally fine. So let's take fungi and go for it. So fungi is 6% of what?
8.7 million.
8.7 million. And again, I'm going to do myself a favor so I don't have to convert later and just write the 8.7 million like that. Again, the millions comma would go where the decimal place had been. And I don't have to type the comma into my calculator. It just helps me write my number. So 6% of means times 8,700,000, no commas in my calculator. And I find out from just the fungi, I have 522,000. So starting from the back in order to read it, 1, 2, 3, 522,000 fungus species. That's a lot of fungus, including mushrooms. Now what? I picked one and went for it.
Now, do we do the other one?
Yeah, sure. Okay, so the other one we're included in is plantae. So we'll do 16%. Again, 16% of what? It's going to be of that 8.7 million. So 8,700,000. And again, my calculator can handle 16. Then the percent button. And then of means multiply, and 8,700,000. And I get 1392000. To read that back, I place in my commas, that's 1,392,000. Now what?
It's asking for how many species. Is it asking for both or just the one?
Yeah, exactly. Where it says or, one from there would be good, one from there would be good. So yeah, it's exactly asking for both. Great question. So what shall I do? Mathematically, if I want both these groups.
Can we just add it?
Yeah, we'll just add it. Mathematically, if you want both the groups, you just want to stick a couple different size groups together, you just add it. Exactly right. See how we're working on our word problem interpretation skills? So yeah. I will add it. And I'm so lazy, I don't even want to type the numbers. And I know that I can arrow up in my TI to grab numbers. So I arrowed up to my first number, the 522,000. I press enter and it selects it. Then I press plus, I arrow up to the second number, and press enter again and it selects it. And I don't even have to retype it in and stand a chance for error again as I retype numbers. And I got 1914000, and that is the total of those two kingdoms, fungi and plantae. I am done. I'll just label this so we understand that. Species in both fungi and plantae together. Is that cool?
Yeah.
Wonderful. So you can see why this skill might come up on science. That's a science graph that I'm talking about. And yet they're using math there. Certainly could come up on math too, don't get me wrong. Can I just reiterate again that the biggest skill that we're learning here today, you might only have one circle graph on your test or 1% problem. So the biggest skill is not how to do circles and how to do percents. The biggest skill here is really how to read a word problem, because I guarantee you half your tests will be word problems. Okay, so C. How many species are not in the kingdom Protista? That's a weird question. How many species are not in the kingdom Protista? What am I saying here?
So they're asking for what's only in the amount of the population that's not included in the species? I'm not sure.
Yeah.
Me neither. I just don't understand that one.
Yeah, it's confusing, isn't it? Okay, so how many species are not in Protista? Let's start with those who are in Protista. So we see those who are in Protista are right here, right? But I don't want them. That's the
okay.
I don't want. I do not want the Protistas. Because I said how many species are not in the Protistas. That means I want all the other ones. Once again, just off the top of my head, I could think of 3, maybe 4 different ways to approach this problem. Okay, so if again, I'm sitting here as a teacher, I'm on which way am I going to teach? I'm not going to teach all 4 because you'll all be pissed at me. I got to pick a way. So any thoughts here? Not in Protista.
So it will be 85% of
Oh,
the total.
that's so cool. Where'd you get that number?
Because we just remove 15% from 100.
That is so brilliant, and I love that you said it, because that is the way most mathematicians would approach it, only because it's the shortest way. They said if the whole circle is 100%, 100% for the whole circle, and I do not want the Protistas, I do not want the 15%, I'll take out that 15%. That leaves all the other ones being 85%. So that was a really brilliant way to think of it. Not all students consider it that way, so let's make sure that makes sense to Serenity and James. Do you guys see where our 85 came from?
Yes.
Cool. So I could just take 85% again of what?
Of the 8.7 million.
Exactly, of the 8.7 million. Okay, let's give it a try. So 85, my percent sign of means multiply, and to get 87 million in there, I do not need to type in the commas. And I get 7,395,000. Now, I'll just tell the entire internet that that is not the only way you could have done it. Like I said, I could think of 3 different ways off the top of my head, but all good math, it'll all work. It'll all get us to the same answer in the end. So if you didn't get this answer, your math didn't work. And I'd love to hear about it in the comments if you found it a different way, if you thought about it a different way. Let's move on now. Let's look at D. D says, approximately what fraction of known species belong to the kingdom Animalia? Okay, guys, what am I asking you to do?
Convert percent into a fraction.
Convert a percent into a fraction. And I gave you this word, approximately. Permission to use a visual approximation. Okay, now I only have a few answers here. 1/3, 1/2, 2/3, 3/4. If I were to make a perfect fraction, which would be, what's the percent for Animalia right now?
Animalia, 62.
Yeah, Animalia is 62%, and we know that 62% literally means 62 out of 100. If I were to do it that way and then type it into my TI to reduce it, I would have a problem. I would, in that it would give me this fraction that is not in my list. 31 out of 50 is not there. Okay, so again, my algorithm has failed me if I'm not a good estimator. Anybody have any thoughts about approximately what portion of the fraction, what fraction of the pie this is?
3/4.
3/4. I am going to now test your hypothesis. Ready? Here's how I would test it. If you think it's 3/4, you're saying that you think that this piece, this blue piece here, is 3 out of 4 total pieces in the graph. Okay, so I could break this into 3 pieces. So let's see, 1, 2, 3. Do those look pretty equal to you?
No.
No, you don't like my drawing?
I will say 2/3.
Well, okay, I'll test yours in a second. Let me test my 2/3 first. I mean, my 3/4 first. So there's 3, right? Serenity, do those 3 blue pieces look pretty equal to you? Okay, yes. So I want about this same exact size to be my 3/4. So let me draw this size again. Okay, did that work? Do I have 4 equal pieces of which I have 3? No, look at all this extra. So yeah, I don't just guess, I check my guess. So didn't work. Okay, so what was your guess, Maricela?
2 of the 3.
Okay, so that means this would be 2 of 3 total pieces. So let's break this in 2.
Yeah.
And then let's see, if we took this piece right here and duplicated it, yeah, I'd say 2 out of 3. 2/3 looks like a good breakup of this pie. So
Yeah.
don't just guess, check your guess. And you might have to do it by drawing it on your whiteboard when you go to take the GED, especially if you're not a visual learner. I'm not a visual person. I am good at it now because I've done fractions long enough, but I've always used to have to draw my little circles out. Okay, even though this isn't my favorite kind of circle graph, I don't actually like the 3D circle graphs because I feel like they distort the size of the pieces. Sometimes it's hard to tell how big a piece is, depending if it's closer to you or further than you, can like distort its size. So I don't like that about these graphs, but however, some people love them because they think they look pretty. So a lot of people make them, so we might as well know how to interpret them, okay? So that being said, I see this little 3D circle graph here, and let's take a look. It says the graph shows Juan's proposed budget for 2019 based on his current salary of $33,600 a year. And A says Juan spends about how many times as much on his mortgage as he does on his utilities. Interesting. What are they asking me to find?
They're asking you to see how many times more he spends on his mortgage versus utilities.
Yeah, how many times more he spends on mortgage versus utilities. And do notice that there was wording in this problem that gave you permission to approximate. See the wording?
Yes.
What word here tells me I'm allowed to approximate?
About?
Tells me, yeah, about. Juan spends about how many times? So permission to approximate, granted, okay? So basically, I'm saying if I take this utilities, which is about 8.1, but I got permission to approximate, so could we just call it 8? Is that cool with you?
Yeah.
So 8 times what? Again, it said how many times, not how much more, how many times. So 8 times what is equal to 40?
5.
Yeah. So how many times as much? 5. I always try to slip this how many times as much in because it comes up a lot with graphs. And for some reason, it's one of those problems that students really screw up a lot. We good with A?
Yes.
Yes.
Cool. Then last problem in the set. You guys are blowing it out of the water today. You're brilliant. B says, if Juan decided to cut entertainment back to 5% and food back to 10% of his income in order to start saving, how much would he put in savings in 2019? Guys, this is the kind of junk I expect from the GED. There's a lot going on here. We need a plan. So first of all, where are we going? What are we looking for? What did they tell us to find? What's the thing we're looking for? I'm going to start with just this phrase here. Here's where they told me to find something, right? They said,
Yes.
how much, there's my question, how much would he put in savings in 2019? So you're right. It's how much would he save? And if I say in 2019, what period of time am I talking about?
12 months.
No.
2019 is a month?
A year.
Okay, so we're asking how much will he save in a year? And then Maricel is seeing all the changes he makes. And he's going to spend less on entertainment and he's going to spend less on income. So if he cuts back entertainment and income, this is what they're asking me to find. And I really, really, really want to know where I'm going before I start throwing numbers out there because I see a lot of students who just pick up their calculator and start crunching in things. They don't know when they're done. They don't know what any of their numbers represent. They pray that they did enough mushing and then they just go with an answer. It's not a very good plan. There's our plan. How much will he save in a year if he cuts back on entertainment and food? Okay, so let's go figure out about the cutting back piece that Maricela wanted to explore. So let's look at entertainment first. We can see that currently he's spending 7.4% on entertainment, but I want to cut that back. What am I trying to cut that back to?
5%.
5%. So we have this chunk, 7.4%. We want to cut it back to 5% so we can use that remaining piece for savings. Now, what students don't often realize is that you can add and subtract percents. We learned since Maricela showed us that on the last problem, taking 100%, taking out the 85. But we can start with that 7.4% and we can subtract out 5%. You know, we can always subtract the same kinds of things, percents from percents. Now, we can't subtract dollars from percents, but we can do percents from percents. So that means that that remaining 2.4% from entertainment is going to get used for savings. Okay, let's do the same thing with food. Let's go look at food. Currently, he's spending how much on food? 11.1% currently on food, but Juan wants to cut that back to how much of his income?
10%.
10%. So we're going to cut out that 10% and we'll use the remaining bit on savings. So 11.1% minus 10% is
1.1.
1.1% on savings. So now look at that. We've managed to slice out little pieces of savings from our income. 2.4% and 1.1%. Ooh, I was trying to clue you in when I said and. We're going to take 2.4% and we're going to take 1.1%. Mathematically, how could I put those two things together?
Add them together.
Add them. They're percent and percents. They can add. Okay, so 2.4% plus, and I don't even bother to type the percent sign in my calculator. It's not necessary because, of course, percents plus percents are percents. And I do get that he's going to save 3.5% in a year. Is everybody cool with that?
Yes.
Or can you see how I'm not done? So many students so proud of themselves they figured all that, but I'm not done yet, am I?
No.
Yeah, I need to figure out 3.5% of what and put that amount into dollars. So 3.5% of what?
$33,600.
Great. And before I do this math, I just want to make sure I know what I'm finding. This $6,000, this represents what portion of time?
The whole year.
A whole year. And I'm looking for a whole year. So I'm good to go. This is the last calculation I need. This will give me the savings for a year. Does that make sense?
Yes.
Okay, so 3.5% of means times and 33600, and I get his savings for the whole year. He's going to end up saving $1,176. Not much, but still better than most of the rest of us are doing. Good job, Juan. Okay, very tricky, complex problem. Lots of steps. Very GED typical. Is anybody mad at me?
No.
No.
Okay, so you guys already know this. You know this. When Kate's in there in class and looking at the problem with you and asking the leading questions, it always makes sense. It's like, I know all the right questions to ask. But it's a whole other thing to do it on your own when you're nervous and you're facing the test. So please, 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 please do not go away, turn off this video, or leave class today and not practice. Okay, so thank you for joining me, guys, in another virtual GED class, and I hope you'll join us again next week. This time we're going to focus on how to find percents of the numbers. How do we find these percents on our own if they're not given to us? We haven't really looked at that yet. So that'll be next class. See you then.